Hello everyone, welcome to another Codeforces stream. Looks like we got about 8 more minutes. Plenty of time to get hyped, get energized. See if we can get the first one in like 5 minutes, 2 minutes, 1 minute. Yeah, it's good to be back. I guess the last week I was in Yellowstone on a family vacation. I feel like I've taken a lot of vacations this summer, but it's been nice. I saw geysers for the first time, and they're sort of incredible. I always thought they just like had just a little spurt of water every hour or so, and were sort of boring. But actually, a lot of water is stored underneath there and comes out really quickly, and it's pretty cool. Like I think Old Faithful shoots about 100 feet into the air, or more than 100 feet into the air every 90 minutes, and it goes for like 5 minutes or so at a time. I was also able to catch Castle Geyser and Daisy, and some smaller ones. Oh, thanks for gathers. Appreciate it. Oh, that's interesting that the stream capture captures me adjusting the volume. Yeah, thanks for following. Are you a Magic player, hence 4gathers, or is that just a name you like? Yeah, so this is just a Div 2. Unfortunately, in the last one, we didn't quite get the last question. I forget why. I think there were just like a bunch of off by 1 errors that I never completely corrected, or maybe my solution was just never actually entirely correct. But for whatever reason, my rating went slightly down. But we're still above 1800, so definitely with just a medium showing today, we should be able to get to Div 1. Let's double check. Where's my, yeah, 1832. Yeah, just lost 61 points. Oh, we were so close to 1900, but I think the problem is I only do this very sporadically. Like, I feel like I should try to do like every single one, but I only really do them when I haven't have time, and I'm always on vacation, so I'm like chronically out of practice. But I'm sure this one will be good. I remember to pre-open the directory that has this contest files, so we won't have to like waste 5 seconds clicking. That'll save us a whole point or something. Let's see what else is new. Yeah, I'm actually considering getting back into tech, so I guess it'll be good to get some practice here. I actually have some interviews tomorrow, and I talked with some companies last week. I don't know if like I want to spend the next 2 years doing math research, and I'm like sort of wrapping up 2 papers now, and I don't know if I really want to start the next thing. Maybe I might just want to do something completely different. But I don't know. I guess I'll think about it. But in any event, I actually need to practice for more than just entertainment then. Though I understand interviews might have shifted a fair bit, and they might focus more on actually demonstrating the ability to code something useful instead of like these strange algorithmic problems, which I quite love. I think they're delightful, but maybe are slightly useless. Who's to say? Well, let's see who we've got writing this one. Tusuzg, Basaka 13, Calvin Jin, JJ Leo, and Serval. Oh, Serval is a kind of rodent, right? No, it's like a kind of cat. I know that from Magic Cards. It's where I learn all my esoteric vocabulary words. Three more minutes. I'm thinking about getting a new keyboard. This one double O's sometimes, and some of the other characters double click as well. I think I might just get like a really cheap basic keyboard, like the kind that come with Mac computers that are very flat. But I do like the clickiness, though it's probably worse from a streaming perspective to have an extremely clicky keyboard. I don't know. I actually, when I watch a stream of a programmer that has a clicky keyboard, I kind of like it. I think there's something like therapeutic about it. Little Mac keyboard. You don't like that one? I'm looking for recommendations. I haven't really used one of those for long periods of time, so maybe it's like shitty to not have like the full range of finger motion. Oh, yours also has this doubling problem? Okay. Maybe I should just work around O. Like, it's not like I'm writing natural language, I'm writing code. Every time I'm going to name a variable with an O in it, I could just leave the O out. Or double O it. How have you been, Scruffy? Been a while since the last stream. Hmm. 2 more minutes. Got my coffee. I feel like too energized actually. Like I want to be double clicking all the keys and I'm gonna be like, it's the keyboard, but really it'll just be me being jittery. I've been well. Yeah, I was just saying how I was in a Yellowstone the last week. That's why I missed the last one. It was really, really awesome. First time for me. One more minute. Let's see if I've got everything up. I've got I got my text editor. Got my notepad. Where's my pen? Oh yeah, it's right over there. Okay. 1 minute 16 seconds. Maybe I'll pre-put on my like nice little felt half glove for tablet purposes. Actually, no, that makes it impossible to type on and off. I don't like how my GoPro makes it look like I'm looking more over the camera. I feel like I should just tape it to the middle of my monitor and then, I don't know, just work around the fact that it's in the middle of my monitor because it's a big monitor, so I can just put my windows on the side. I wonder if there's like any software that like, because I know there's software that will like take a picture of the side of your face and like project it to the front, and it's like surprisingly good. I wonder if there's like any that'll adjust the angle of your eyesight, so like if it'll make you look like you're looking at the camera instead of right over it. Yeah, I actually think the fisheye effect is cool, but maybe it's actually sort of amateurish. Yeah. Okay, here we go. 5 seconds. No more time for chit chat. Gotta get this fast. Yeah, maybe I should just get a normal webcam. Okay. Mocha is a young girl from high school. She has learned so much interesting knowledge from her teachers. Learning about binary systems, bitwise operations. So she gets a sequence of length n. In each operation, she can select an arbitrary interval. And for all values in the interval, from 0 to r minus l, she replaces... Oh, okay, so from AL to AR, she replaces the value with okay, so she replaces the value at AL plus I with the bitwise and of it and the thing at the end. Okay, and yeah, this is commutative, so the two things will become the same. So she can perform this operation any number of times. And what does she want to do? She wants to minimize the maximum value in the sequence. So bitwise and is strictly decreasing. So if I take any value and bitwise and to something else, it'll get smaller. So yeah, the answer will just be the bitwise and of everything in it, because with this operation you can get anything to be bitwise anded. So yeah, that's the answer. So input is processed correctly. Okay, so then answer equals, I'll just answer equals line at 0. And then for I in range, so for I in line, answer equals answer bitwise and I. Then answer. I think that should be right. So first I read in the number of test cases, and then, oh, I need to read in a line that tells me nothing. Great. Okay, 0, 1, 3, 3. Looks correct. Fingers crossed. I hope it was right. We beat the 3-minute mark. I feel like we should be aiming to beat the 2-minute mark, though. I guess I waste time like reading because it's streaming. Okay, running on pretest. Should probably just go on to read the next one. I'm pretty confident that this is right. No. This happened the last time too, actually. There's some like I guess like everyone just spams refresh right away. Okay, looks like it was accepted. Nice, 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 nice. Okay, so next mocha and red and blue. Okay, so there are n squares arranged in a row, and each of them can be painted red or blue. Among these squares, some have already been painted and others are blank. I can decide which color to paint on each blank square. Some adjacent squares are the same color, which is imperfect. The imperfectness is the number of pairs of adjacent squares that share the same color. Okay, so this is 3 because we've got RRR and BB. Okay, and then our goal is to minimize the imperfectness after painting. Okay, so then we get the sequence, some of which are R and blue, and some of which are left for us to paint, and we want to minimize the imperfectness. Okay, so I think greedy should be fine. Yeah, so if there's like an R here, then there's no reason not to paint a blue here and then an R here, and then eventually you'll run into another colored one, and if you're lucky it was RB, and that's obviously you can't do better than that, and if you're unlucky it's BB, but if you switch this to R, then at some point you'd have to switch back. So yeah, I think greedy should be fine. The one thing that annoys me is I want to just scan from left to right, but like this first question mark, we can just cut off all the trailing question marks because we can always paint the trailing question marks perfectly, because if this is R, we can always paint this blue, and if there was multiple question marks, we could just propagate backwards. Okay, so let's open up B. Yeah, so it looks like we've got the same kind of thing where they'll tell us N. And looks like the line is actually a string, so I'll just get rid of this logic. Okay, and then yeah, let's trim off the leading question marks, and then let's go from there. So okay, so found color equals false for C, so C for color in line. If found color equals false and C is a question mark, then I'll just continue. So the answer in the beginning is 0. The last color found, I'll just define to be a question mark. Okay, so if maybe I'll list this. Okay, so if this equals question mark, then we'll continue. If So if C is, what is it, like capital R? Yeah, capital R for red. Then last should equal R, and found color should equal true. Same thing for B. Okay. Okay, this is sort of horrible. I can just say found color equals true at this point, and I can just say that last equals C. Okay. So then if I've found a color, so if C equals question mark, and I've found a color, which I have if I'm at this part of my code, then I just say sort of annoying. So if last equals R, then now last should equal B. I should just swap it, and vice versa. And then, so that's if C equals question mark, I don't have to do anything. If C equals blue, yeah, if C equals blue, and so at this point, let's just continue. And then if C equals blue and last also equals blue, then our imperfection increases, answer plus equals 1. If C equals R and last equals R, again, our imperfection increases. Maybe I'll make this an OR. I don't know. This doesn't really make sense. I'm not really saving time considering I've already written the logic the other way, but I guess I'm saving logic because I don't have to write answer plus equals 1 twice. And in either case, if C is not question mark, I can just let last equal C. And then I can print the answer. Yeah, Scruffy, that's probably better. Yeah, I didn't realize strip took an argument and I could strip off a character I specified. I thought it was only for white space, but yeah, actually that would be better than this logic that I start with here, like if found color equals false, for sure. Wait, equals false, that's not very idiomatic. Not found color. What? Oh, right. There. Okay. Oh, I actually need to. Oh, that's annoying. I didn't realize I had to actually compute the answer. That's really annoying. I probably should have read more carefully. Okay. Let's just make sure that I'm getting the right imperfection. So here the imperfection is 1. Wait. Here the imperfection should be 0, right? Wait. So these aren't quite the right answers. Yeah, of course this should not have any imperfection because after R, just fill in these question marks. Oh, do I not? Wait, How is it? I don't understand how this one's wrong, because after it fills in the... So it shouldn't increment answer on this part, and it should always continue. And then when it gets to R, so... Yeah, so last equals C. Oh, and then I need to continue. Then I need to continue. Okay, so what's happening here? Is that a joke, or can I actually not strip? Oh, right. Now that we know we need to actually find the answer. Of course, we can't strip. We need to actually use it. Yeah, I guess we might just need to kind of like redo it. So answer equals times n for I in range n let's just like pass left and then pass right. So if answer so if line at I does not equal question mark, then answer at I should just equal line at I. And then if line at I, so if line at I equals question mark, then if line at I minus 1 if I equals 0, continue. Otherwise, if line at I minus 1 equals R, then answer at I equals B, else answer at I equals R. And then let's just print the joining of this. And I'll just delete the rest. Okay, this doesn't really make sense. So why is it not exactly the same? Wait, I'm loading n, right? N is defined. I don't need found color anymore. So I just iterate from 0 to n minus 1. If it's not equal to question mark, then I just fill in what it is because I can't change it. If it is equal to question mark, then I don't fill in at 0, but otherwise I define it to be the opposite of what it was previously. Oh, I should let this be I should just compare to answer. So if answer I minus 1 equals R, and I'll just make this an if 2. The heck? Wait, so but I get to 1, and then answer at 1 should equal R, and then as if I continue and I get a question mark, then the previous one should be R or B. What's going on there? Just print line at I. I feel like I'm missing something obvious. Line at I goes question R. Okay, so when it equals R, then it doesn't equal question mark. So I should let answer at I. Oh, what? How is this not an error? Python, please. Python needs to save me from myself. Okay, so then it goes R, B, R, B, B, R. Okay, then I just need to fill in the trailing things. Okay. Okay, and then let's just say answer okay, and then just go backwards for I in range. I don't want to do this. This is so stupid. I should have made maybe this a function, and then I could reverse it, call the function again, and reverse it or something. But I'll just iterate backwards. So for I in range, we'll start at n. We'll go to 0. We'll step backwards. If answer at I. Okay, I guess I should start at -2. So if answer at I is a space, then do the opposite of this. So if now +1, and yeah, just flip it around. Okay, what's with all this printing? That doesn't look great. Let's see. So the first one, BR. Okay, so mine's not the same as theirs, but I think we can print out anyone. Yeah, print any of them. So ours isn't the same as theirs, but it's the same thing. This one is perfect and consistent. Okay, what's... Oh, so we don't handle the single question mark correctly? Oh, okay. I'll just make that a special case. If line is just a bunch of question marks, then let's just print let's just print BR times n/2 and integer division over 2 +1, and then just print out the first n characters of that and continue. is not the best, I think, but doesn't like that. But now is it printing out 0 characters? No, it's printing out 2 spaces. What the heck? Maybe it doesn't like this comparison. So if B not in line and R not in line. Int object is not subscriptable. Okay, so it works. Let's see if this last one is right. B, R. So we're always kind of greedy. So here, okay, so B, R, B, R, R, B, R, B, B, R. Yeah, so theirs is like greedy in the opposite direction, but it's the same thing. Okay, let me just make one more test. Okay, and let's also test the even logic. Those look good. Okay. Yeah, I think I made this a little more complicated in some places than it need to be, but I think it should be correct at this point. It's sort of slow, but whatever. Nice. Okay. 24 minutes. I feel like that should have been a 10-minuter, but whatever. We got it. On to C. Yeah, this one we were into the top 600. Now we're in the top 3,000, so we're falling behind. But whatever. Onward and upwards. Or more like onwards and onwards. There's no real up or down. Okay, the city where Moko lives is called Zhejiang. There are n+1 villages and 2n-1 directed roads in the city. Okay. There are 2 kinds of roads. Oh yeah, so it's like it's sort of a directed tree. Okay, so there's n-1 roads from village I to village I+1. For every I. Oh, okay. I thought neighbors had n-1, and then I was like, why is this not quadratic? But okay, no. So there's the forward roads. There's a road that goes forward from each village to the next village. And then there are n roads which have a different sequence, A1 to AN. So if AI equals 0, then the ith road goes from village I to village n+1. Otherwise, it goes from village n+1 to village I. Okay, so the first. Okay, so some of the villages are randomly connected to the end, and some of the villages have the end randomly connected to them. Okay, so every village can either jump to the end or have the end jump to it. Okay, that's an interesting condition. Okay, so Moko plans to go hiking. Oh, I love hiking with Taki. To avoid the trip being boring, they plan to go through every village exactly once. They can start and finish at any village. Can you help them draw up a plan? Oh, I bet we have to just compute the number of ways to do that. Okay. So the first line contains a single integer t, the number of test cases. Each test case consists of 2 lines. The first line contains a single integer, indicates the number of villages is n+1. Second line. Oh, so there's no path from the last village, the penultimate village to the last village, necessarily. It will go one direction or the other. Okay. The second line of each test case consists of n integers. Print a line with n+1 integers where the ith number is the ith village they will go through. Oh, we don't even need to compute the total number. We just have to compute a legal path. Okay, so the setup is like, let's see. okay, the setup is like there's n villages, n, and then there's some special distinguished village, n plus 1. Okay, so these villages are always connected one to the other. And then this village up here is special and has some that it comes down to and some that it goes up to. So there are some that come up to it. Oh, and very importantly, it's sometimes going to be impossible. If the answer doesn't exist, print -1. I guess that's not the case in the outputs they gave us. Okay, but let's see. So we want to go through every village exactly once. So the only way we're going to be able to do this is if, so we're walking along. We can start anywhere, right? They can start and finish at any village. But we don't want to start and finish at the same village, right? Yeah. So here we go. Yeah, we can go 1, 2, 3, 4, or we can go 1, 4, 2, 3. Okay. Okay, so there's no way to double back except by going through this village up here. Yeah, because these villages all go forward. The only way to go backwards is to jump up and then jump back. But you can only do that once because you can only go through this village once. So I think the answer, if it exists, is always going to be of the form 1 to up to k, and then k goes up to the n plus 1th village, and then you continue. So you need to just find some place in the sequence where it goes 1, or 0 means you can go. So you need somewhere where it goes like 0, 1, and then you can jump up, down, and keep going. Okay. So, so it actually will always be possible. So if there's somewhere where there's a 0, 1, you can do this. I guess we're not quite there yet. If there's somewhere where it's 0, 1, you can do this. Alternatively, if it's all 1, then you can just start here. You can go n plus 1 to 1 to n. And if it's all 0, then you can go 1 to n plus 1. And if it's not all 1 or all 0, then either there's going to be a 0, 1 or a 1, 0 if it's like this. But then this is also possible because you can just start at a... Yeah, you can just find the 0, 1, and you can just start at n... Oh, wait, no. Is this possible? Because... yeah, so these are all going forward, but in this case, your n plus 1, these are all going up to it. Oh no, if you end with a 0, it's always possible. And if you end with a 0, then either it's all 0. Yeah, if you end with a 0, it's possible. If you start with a 1, it's possible. If you don't end with the 0 and start with a 1, then there must be a 0, 1 somewhere in you. Okay, yeah. So it's always possible. Okay, so let's code up some logic. So what do we get? We just get the inputs, which are uh, 0 or 1. Okay, so if one is not, or not one the string, but one the number is not in line, then what's my answer? How many? There could be up to 26. If one is not in the line, that means they're all 0, which means we can go to the last village. So I just want to print out the sequence. How long can this be? It can be up to, okay. I'll just pre-compute it to reuse it. So let's see. I'll call it sequence equals 0 times, or I guess it should equal the, I'll just make a list of the range that starts at 1, goes to 10 to the 4th, and inclusive step size of 1. So if 1 is not in line, then I'm just going to print out, oh yeah, that's an abbreviation. So it should equal the sequence that goes up to n plus 1. Yes, and it starts at 1, so that should be the answer. If 0 is not in line, then I want to print out the sequence that, again, now I'll just go up to n, but I want to just have n plus 1 up front. So I'll just put continues here. Okay, and then if so I know at this point I know 1s are in the sequence, I know 0s are in the sequence. If it ends with 0, then I'll just, so if 0 is, I'll just say if 1 not in line or line at the end is 0, then I'll do this. And now at this point I know that somewhere in the sequence there is a 0 followed by a 1. Because it does contain zeros, but it doesn't end with a 0, so there's somewhere with, okay, so yeah. Then I just need to find the index of that. So for I in range n, if line at I equals 0 and line at I plus 1, I don't need to worry about this being out of bounds because I'll have bound up for the end. If that equals 1, then I've found my answer, so I'll just, so what is the answer? So I print the sequence that goes to I, and then I include n plus 1, and then I go from there. This might be off by 1, but we'll double check that. And then I break. Let's see how that looks. Oh, I guess I need to concatenate these things. Just make sure this is long enough. Texture. So just space.join. And same thing here. Yeah, I really need to get a new keyboard. Expected string instance integer found. Oh, I hate that. I hate that. Okay. It's very annoying. You know, I can kind of just make them strings here, I think. Stir. So stir I for I in. And now I don't need to cast it to a list, though I don't think it matters either way. Change that. Okay, now all these n+1s, I should also make strings. One, two, three, four. 1, 2, 3, 4. Plausible. Let's see if that's a valid solution. So the first test case looks like this. So 1, 2, 3, 4 is a valid solution, and for the second one, 1, 2, 3, 4 is also a valid solution. So I guess they didn't really give us very testing test cases. Maybe I'll just check all three pieces of logic. So let's just do one where they're all 0. Okay, that one looks like 1, 2, 3, 4. And then let's do one where they're all 1. So yeah, then 4 is at the front. And let's do one where it starts with 0 and then goes to 1. So, what? Oh yeah. So 1, 4, and then 0, 0, 1, 1. Okay, so yeah, then it goes 1, 5, 2, 3, 4. And this is actually incorrect. It should go 1, 2, 5, 3, 4, I think. So unsurprisingly, there's an off by 1 error here. I think it should go up to I+1 and starting at I+1. 1, 2, 5, 3, 4. Yep, that looks right. 1 in line. Oh, no, these are actually correct because I changed sequence to be a sequence of characters, but yeah. Yeah, but line is line actually is cast to integer. Hey Ron, how's it going? Yes, I think this is correct. Just double check that I didn't break anything here. Yeah. Okay, so submitting. You okay? You're like sniffling. Is it smelling here? We need to have like smell-o-vision in
Just
Twitch.
pretend I'm not here, Jake.
Okay. Let's see. In the queue. Let's see what D is about. Is Codeforces lagging again? It's taking a while. Maybe my solution has crashed Codeforces.
It's too powerful.
Yeah, it is too powerful. D. We get an easy version and a hard version. The only difference between the two versions is the constraint on n. You can make hacks only if all versions of the problem are solved. Okay. Oh, right. This is one of those contests where you can like hack each other. I never really do that. It's always seemed mean-spirited. Though maybe it would be actually useful to read other people's solutions, learn something. Okay, so a forest is an undirected graph without cycles, not necessarily connected. Mocha and Diana are friends in Zisheng. Both of them have a forest with nodes numbered from 1 to n, and they would like to add edges to their forest such that after adding edges, both of their graphs are still forests. They add the same edges. Oh, and they want to know the maximum number of edges they can add, and which is edges to add. Okay, so we're going to get 2 forests. And then for that forest, we compute h, the maximum number of edges they can both add. And then we actually need to compute the edges they can add. Okay, and each of them, oh, they don't necessarily have the same number of edges in their forests. Okay, that makes sense. Let me just double check to see if a submission was, it's still in the queue, huh? I guess Codeforces is being laggy. Okay. Okay, so this is the easy version, and the hard version is the constraints on n. Okay, so in this one, n is less than 1,000, and the other one, I guess it's probably like less than 1 million, or probably less than 10 to the 6. I'll double check that though. I guess it's substantially harder when you can't do a quadratic solution. N is, oh, 10 to the 5th, okay. Okay, and there were a lot of clarifications to this problem, right? Where can I go to see those? I thought they were supposed to show up somewhere, like announcements. There were like 5 of them, right? But, oh, I can really see them. Okay. Hopefully, whatever the clarifications were, they weren't important. Okay, so we've got 2 forests, and so that's 2 forests on the same vertices. So maybe like this and this. And we want, oh yeah, so forest number 1. And then we have another forest, which maybe looks like this. Maybe this one looks like this instead. And we want to find the maximum number of edges we can add to both such that they both remain forests. Interesting. Okay, so if it was just one forest, then what we would do is we would like partition it into different trees. So we'd have like tree 1 here, and tree 2 here. And then we would just partition it with DFS, and then we'd go from like one group to the other, and we could just connect an arbitrary vertex in this tree to an arbitrary vertex in that tree. I'll give that a different array, I'll dash it. So yeah, we just add that, but we could add any of them and they'd all be the same. But this one is different because we've got 2 forests now. So we got like this one down here and this one down here. So now we wouldn't want to add this edge because it's already present here, but we could still add like a variety of edges. So now like something like this would be good, and it would make both of them into a tree. Let's see, so I think something vaguely greedy will still work. So I think if you can add any edge such that it doesn't connect 2 vertices in the same tree in both forests, and that'll be fine. Yeah, as long as you don't do something that would connect 2 trees in the same forest, what can go wrong? Or can something go wrong? I guess what's the same tree changes when you add the first edge. Okay. Okay, so what am I picturing? I'm picturing we do DFS on these 2 forests. And so like after that, the first forest looks like tree 1, which is just like a set of like the vertices that happen to be in it. And we've got tree number 2, which is the ones that happen to be in that. And then we have forest 2, in which we've got tree number 1, which has the vertices that happen to be in that. Put a prime there too, more primes. And we have all these collections, and then what do we want to do? We want to connect, like in the best case scenario, we would connect all of these trees. So we'd we'd connect A1 to B1, B1 to B or to C2 or C1, and so on. And in the best case scenario, all of these would be fine by forest 2, and then we'd be done because we couldn't do better. One second, I'm just gonna check to see if this has been finished grading. Still in the queue, huh? Weird. I hope their computers are going okay. Okay. So in the hard version, we're going to need a linear time algorithm. In the easy version, a quadratic algorithm is fine. In fact, in the easy version, even a cubic version would probably be fine, right? No, it's 10 to the 4. Yeah, it's like 1,000. So even a cubic version, probably quadratic, but plausibly cubic would be fine. But in the hard version, we'll probably need a linear solution. Okay, so DFS, that's fine. That's linear. So we can get these partitions, and then we just need to like make them consistent. Uh, hmm. So thinking about an easy solution first, we could just iterate through all possible pairs, um, AI, BJ, and check if they're consistent with our tree, our forest in the other part. So um, a slow solution, iterate through all AI, BJ, add first one that's consistent. Is good with tree 2. And okay, so if it is good with force 2, then it'll also necessarily collapse 2 of these trees down to 1. So I guess there's 2 things I'm worried about here. One is maybe the collapse is not optimal, but I think that should be fine. I think that reading it should be fine. And the other thing I'm worried about is like maybe we can't connect um hmm maybe we can't connect A1 to B1 through this, but we can like connect them both to C. Um, so maybe just iterate through all A, I, X, X not in A, and then add the first one. And yeah, I think that should work. And yeah, it'll be quadratic. Yeah, for each. Yeah, and then once we add one AI to something not in A, then they collapse to the same one. And we keep going. Yeah, maybe I'll code this up and not worry about linear time yet. Though I don't know. If we can think of a linear time solution, we can do them both at once, and that would be obviously much preferable. Um, hmm. Yeah, I wonder if there's. Hmm. I wonder if this is secretly 2-sat or something. Cause yeah. Or so we're trying to maximize the number of edges we add, but I guess more than that, we need to actually find which edges we're adding. Yeah, I guess 2-sat's never really a maximization problem, but I guess there is some kind of like logical thing going on where like a tree in the forest is sort of like saying you can't connect these collection of vertices. So like we can't connect these collection, we can't connect these collection, and but I guess I can't add like a proposition for every pair because that would be quadratically many propositions. So that's not good. Okay. I think this will work, but I kind of want to read the last problem statement before committing to trying to code that one up. Let's just, oh, cool. So we did get C, nice. I guess all we have is speed. We like got this one in top 600, and now we're like 3,000. Pretty bad. Yeah, it does seem like D1 is probably much easier than E because only 100 people got it, but people read them in order, so let's just read E. Okay, so Mocha wants to be an astrologer. Interesting choice. So there are n stars which can be seen in Zhejiang, and the brightness of the ith star is AI. Mocha considers that these n stars form a constellation, and she uses A1 to AN to show its state. The state is called mathematical if all of the following three conditions are satisfied. Oh, okay, so there's n stars, and they have some brightness, and their brightness vector is its state, and we want its state to have some property. Wait, what is Li and Ri? So, okay, their integers were given. Okay, so okay, wait, what is Li and Ri? Okay, so we want the state to be contained in some range, which I guess we're given. Okay, so interesting. Okay, so we only want to find constellations of length n, and the ith star needs to be in some range. Okay. We need the sum of all the brightnesses to be less than m. I guess that's also given to us. Okay, and we need the n integers to be coprime. Okay. What? 50 minutes were added to the contest? I don't want that. I wanted to leave promptly at 12:35. Okay. And two states are different if the brightnesses differ. Okay, I guess this is important because if you add a bunch of stars that have the same brightness, it doesn't necessarily change the number, but it could change the number, I guess, if yeah. Okay, so the first line contains two integers, n. Okay, n is less than 50, and m is less than 10 to the fifth. The number of stars and the upper bound on the sum of the brightness of stars. Each of the next n lines tells us the range of the brightness of the ith star that's allowed. And then we want to print the number of different mathematical states of this constellation. Oh, okay. This is sort of a interesting problem. Where are we given A1 to AN? We're not given A1 to AN? So I guess we can just choose A1 to AN? Okay. So if we didn't have this GCD requirement and we didn't have this sum requirement, the answer would just be the product over Ri minus Li plus 1. So in this first case, like the first star can be 1 to 3, the second star can be 1 to 2, so that would be 6. But the GCD requirement, so the sum requirement forbids 3 and 2, that would be 5. And the GCD requirement forbids 2 and 2, because those, of course, have common sum 2. Okay. And then the length is 50. Okay, so 50 is not that long. So I think we can just use dynamic programming and iterate from 1 to n and keep track of the current optimal pair, or the current number of ways to achieve a pair with a given GCD and a given GCD and sum. Yeah. So let's see. So we start at the beginning, and our GCD is 0. Everything divides into into 0. Right, or should I say 1? Yeah. So in the beginning, our GCD is 0, and our sum is also 0. And then we iterate from 1 to n. And okay, so here we've got R1, or L1, up to R1. And for each of these ones, we add we basically just add L1 L1 to our table. So we have like a set of possibilities, and in the beginning there'll be L1 L1 up to R1 R1, and then at 2 iterate over pairs. I guess I'll call it G over pairs G, S, and the new number, I guess, and I guess I'll say K in L2 R2, and then just so I guess these map to not just like this state and the number of ways to do it. So they all have one way to do it in the beginning. And then just add GCD of GK. So add 1 to GCD GK and S plus K. Or the pair of these things. Okay, and then how many things can get into our table? So I guess the sum can get up to m, and the GCD can also be as much as m as well. Yeah, so that's m squared, which is bad. But well, the size of the table is not so important. What's important is the number of operations we're going to do, and we're going to iterate over n things, and at each point in the m things, we're going to iterate over at most m things, and then like we'll just update the state of the table, and compute a number. Yeah, I actually think this problem is easier than the previous problem, for me anyway. So I'm gonna do this one. So this one is E. Okay. So this one doesn't give us a line, it gives us, there's no T. So we first get n m, and then for, I'll make an R and L thing, so R and L, and then for I in range n, I wonder if this works. This probably works. R L-I-R-I. And then I can just wrap this up. Yeah, this should certainly work. Okay. Okay, now I've got all my input. Okay. And let's just compute a quick GCD. There's probably some built-in GCD, but let's just do it ourselves. So if A equals 0, return B. And then otherwise return GCD of B. I think I can just say B and then A mod B, or B mod A, because at this point I know A is not 0. So B mod A. Okay. No, this should be A, right? Euclid. Okay, so if A is 0, then of course I can return B, and then should this be A mod B? I feel like I'm losing information if I do it like this. I think it should be A mod B. Okay, and then I switch their order, which is good. Okay, so if A is larger than B, so if A is smaller than B, then all I've done is switch their order. But then when I do it the next time, B will be larger than A. Yeah, let's just test it. So GCD 1, 5. So 5, 5, 15, 5. Modules by 0. But I already. Oh, should this be? Or B equals 0, return A. There. 1, 5, 5, 1. It's got to be correct, right? And what if A equals 0, but B doesn't? Oh, then I switch their order, and then okay, it's got to be correct. Math.gcd. Oh, thanks, Scruffy. Yeah, you know what? I'll just do that. Yeah, okay. I'll just call it math.gcd everywhere. But I'm glad we can implement it with only like 3 tries. Okay, so what do I want? I want a list of dictionaries. Okay, so yes, I want a list of dictionaries of length n plus 1. Yeah, this is how I always do DP in Python. Instead of like multi-dimensional arrays and thinking about indexing, I just make it a list of dictionaries. So I'll call it state to be as descriptive as possible. So I want it to be of length n, and then I'll just fill it in. Sorry, I literally just said I wanted it to be of length n plus 1. So state at I should just be a dictionary. And then the first one should be distinct. It should be a dictionary that maps 0, 0. So there's one way to get a GCD and a sum of 0, which is the empty vector. Okay, and then I just iterate through. So for I in range n, I guess there's no reason to like keep track of things further back. I could just like garbage collect it, and I'm kind of preventing the computer from doing that by doing it this way, but whatever. So for I in range n, and then I need to iterate from R, so L to R. I always mix up the order of left and right. So from L to R, and I assume inclusive, yeah, so I need to go to R plus 1. And what do I do for each of those? So for each of them, I now need to iterate through all previous states. So for, I guess, GS in state I dot keys, state at I plus 1, so if math.gcd g j, how did I call it j? I called it k in my write-up. So GCD of these and the sum of these. If this is not in that, then I need to add it. State at I plus 1 at that exact thing. So I'll just let this equal 0. And then I just need to increment it. Plus equals 1. Okay. And I guess let's just mod it by our prime. Mod by p. Mod equals has got to be in Python, right? I don't know why this is their prime of choice. I prefer the one that's like 1, 0, dot, 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 0, 7. I think that's optimal. Whoa, it copied it without the spaces. How did it do that? Okay. And that's our state. And then when we get to the end, we just add up all the ones that satisfy our condition. So we just need, okay, so then, okay, answer equals 0 for I in range, I guess M. I can iterate through over M. That's fine. M plus 1. So I need a GCD of 1, and if this tuple is in the last state dictionary, then answer plus equals whatever it is. And I'll mod equal it as well. probably do that at the end, but maybe there's some overflow issues if I add them all up and then mod it. Wait, this one can be easily used in fast Fourier transforms? I mean, like this problem is relevant to fast Fourier transforms, or I could see that. Okay, let's just print the answer. Let's see if it's right. Int object not iterable. So it goes, let's see, 30 for GS and state I dot keys. But the keys should be tuples, should they not? Why not? Why aren't they? When am I ever? Oh, I miscopied this because I yanked to the first parentheses, not the second one. Let me just give this a name. What's a good name for it? At. Four. That's the right answer. No. 22? Not the right answer. Oh, that's not good. Let's just try this one, though. I guess there's no hope for it being the right answer if the other one was not the right answer. Also, that felt kind of slow, which is maybe also worrying. Okay, so we got the right answer for this one. So I need the sum to be less than or equal to m. Okay, so I iterate through the previous state of GCD and sum, and then I compute the next GCD. So this should be right, yeah, because I should include them both. So, and then I should add one to this because of how range works. Yeah, this triple for loop might not be good. I was thinking n times m is fine, but actually for each pair of n and m, you need to look at like everything that you could have reached in the previous state, which I was hoping is small. I think it should be small, but I could be wrong. The reason I think it should be small is because I think there should be a lot of collision in the GCD. I think almost all of the GCDs should be 1. So but that actually is still not good enough, because even if all the GCDs are 1, you're still going to run into this issue where there's a lot of sums you can reach. Oh, we should throw them out as soon as the sum exceeds m for 1. But so yeah, we should throw out all the sums that ever exceed 1 for sure, or that ever exceed m. But then that still could be a little bad because we can't do something that's quadratic and 10 to the 5th. But let's just try to get the right answer first. I think we can do some optimization here around throwing things out that are big. Okay, so I iterate from 1 to n, and for each of them I iterate through the possible things we're allowed to choose. That's to start at L and go to R, And then I look at everything that came previously, and if I compute what the new GCD would be given the previous GCD and this value of j and this sum, if it's not already defined, I define it, and then I increment it, because this is like one way. Oh, it shouldn't be plus equals 1. It should be plus equals the value at the previous vector. I guess I don't need to name this. It's just the same thing as GS. So that's why I gave the right answer for the first one, because it didn't really do anything. Let's test this one. 251. I think, yeah, that's right. Okay. So now we have a correct solution, which is good. But I don't think we actually have a fast enough solution. I think, yeah, let's just quickly write up the worst one. So the worst case scenario is n is 50, m is 10 to the 5th, it's 10 to the 3rd, 4th, 5th, and then the next lines are all from 1 to 50k. So for I in range, what do we print? Just print this again, but it starts with 1. There. Now let's just redirect that into E. Oh dear. Wait, no, that's not right. Warning. Okay, so, I don't want to rewrite it. Yes. Okay. Whew. I guess I want to pipe it. Forget how to do this. Wait. Oh no, this is right. I just needed to like do like that. Okay, this is sort of embarrassing, but let's just make sure we do it the right way. Okay. Oh, and that's why I gave a broken pipe, because you can't pipe to a file. Yeah, okay. Thank you. Okay, but this is going to be quite slow. I don't think this is going to run in time. So we need to think about optimizations. So the first optimization we can make is we can just continue if s plus j is greater than m. It's already too late. Just continue. So that's the first optimization we get to make. But I still don't think it'll be fast enough. We need something else. Yeah, because so as I had written it, this state vector could get as large as n times m. Yeah, and now with this condition, it can sort of only get as large as m, assuming that G is sparse, which I think it should be pretty sparse. But we're still iterating over this thing of size m twice, which is, I think, going to be too much. So yeah, I'll kill this and see if it's fast enough with just this one optimization. Wait. wonder if I should just write worst.py to a file. Okay. And then we can pipe like this, right? Okay. And then this is where it was there. Yeah, okay. I thought this was going to be an algorithm that was like n times m efficiency, but it's not really. So we need to think of other ways to speed it up. And like there's slight optimizations one could make in that, like, if the sum is too close to m, you're going to be doomed later. But I don't think those kind of optimizations are going to get us there. Huh. Let me just check the problem statement for clues. So we iterate through the range L1 to R1. And there's no conditions on L and R except that R can't be stupidly large and we don't have negative things. Okay, and then so somehow we have to keep the state vector from getting too large. But so every GCD is plausible because, like, if you have any number, and this is like a range larger than 1, then there'll be some number in it that'll make the GCD 1. Somehow we need to like keep the sum small. Oh, okay. As soon as the GCD is 1, we can just multiply. No, we... Well, as soon as the GCD is 1, then I think it will reduce to a combinatorial problem. We can't just multiply because we still have to preserve the future sum. But I think we no longer have to do an iterative problem. And as soon as the GCD is... And the GCD should become 1 quite soon in general, like, except on like a sparse set. Okay, so say we go from A1 to AK, and then we still have like some future things to look at, AK plus 1 to AN. So if the GCD equals 1 here, then here all that matters is the sum of the remaining ones is less than or equal to m minus the sum of the previous ones. Okay, and then I think this should be a simpler problem to compute the number of ways to achieve this. So, okay. So, how can we do that? So, if m is large, then yeah, if m is large, then of course we just have the product of ri minus li plus 1, but somehow like we shifted down and cut off a bunch of things, but they don't all start at 1. I don't. Okay. So I'm all of the solutions that first come to mind are sort of like this similar solution where we iterate through starting at the beginning and then keep track of all this state that we don't really need. Like, I don't really want a dictionary that maps all possible sums because there could be m of them to the number of ways to achieve that sum. I think it's like the some kind of multinomial formula. We'll just like do it. So You're in. So if they all started from 1 to k, then how would I do it? I should just Google like formula for this. Hey, let me just refresh my mind about the multinomial formula. Oh yeah, as you can see, I've been refreshing Donda by Kanye West. When's it gonna come out? Multinomial formula. Okay, for any. Okay, so. Yeah, this counts a bunch of things, right? So what was it? Interpretations, ways to put objects into bins. Okay. The multinomial coefficients have a direct combinatorial interpretation as the number of ways of depositing n distinct objects into m distinct bins with k1 objects in the first bin, k2 in the second bin, and so on. So this is sort of related to what we're talking about because you can think of the objects as being, we want to have fewer than m objects, and we've got n numbers to distribute them, and then k1 up to kn should be less than ri and greater than li, but we can't do that computation, so I guess actually that formula is not directly applicable, though it's sort of adjacent to what we're trying to do. Okay. Yeah, so what do I want? I want like a closed form formula for this. I want a formula for this that it can be computed in time big O n, not big O m. Or worst case, big O nm. No, I think I need big O n because I think like we'll need to compute this like m times for like different distributions of this sum and such. But there's big O n data because each of these AI are like clipped on the left and the right at R and L. But there's no real dependence on M. I think we should be able to write down a formula for this that doesn't depend on M. But in order to do that, we have to like not keep track of all this state, and we need to think like a little more combinatorially. Okay. It's tricky. So we take... So the total number of ways to allocate this is the product of the range of the intervals. And then we need the intervals, we're like sort of clipping it down pretty substantially. I wonder if there's some like stupid optimization that we could make that would... But yeah, this is still running, so this is maybe we need some pretty substantial optimizations, but it occurs to me that here I'm running over from L to R, but in reality, these are going to be mostly too big. Like, there's going to be a lot more ways. No, I don't. I'll make the optimization, but I don't think it can possibly help us very much. But I think we can do these things in the other order, and then we can simply not care about... So instead of going all the way up to R, which in like the worst possible case is 100,000, we can just go up to the ones that are still permissible. So we need J plus S to be greater than M. So I can, or we need it to be less than M. So instead of going all the way up to R, I can go up to R. So I need S plus J to be less than M, so I can go to M minus S. So I'll take the minimum of this and M minus S plus 1 plus 2 to be safe. And that should be an optimization, but I don't think it, it actually might help sort of substantially. I think it might help by like a factor of 2, but obviously we need much more than a factor of 2. So it probably doesn't help enough. But that's one optimization we can make. And we can also keep track of the remaining sum. I'll call it remaining. And then, so at each step we can then subtract off Ri. And then, oh wait, no, this is the remaining min is what I care about. No, this won't help at all. I was thinking like you might add some thing GS and then S is like quite close to M, so close to M that there can't be any more valid permutations that start with that. But in the worst possible scenario where all the L's are 1, that's obviously not helping at all. So it can't matter. Yeah, let's make sure I didn't damage the correctness, because I did, I guess, introduce some new logic. Okay. Seems faster, actually. I remember this one actually took a noticeable amount of time to run. Okay, but it's not helping enough. So I think we do need to use this idea that almost always, or like this state is very sparse except at 1, where like the sum is 1, or no, so where the GCD is 1, and then we need to like somehow have a big O n formula for what remains. But it seems difficult. Maybe this problem was harder than I realized. Yeah, I didn't realize we would need any optimization at all. I kind of missed that my solution was quadratic in n. I was just hoping the table was like not going to blow up. Yeah, I wonder if I should just do the tree problem. Like, how much time is left? I guess there's only 15 minutes, so there's probably not enough time for me to code up the tree one. Maybe. I guess it is just like a bunch of DFS. Okay. Didn't they add 15 minutes? Oh, oh, yeah, they did say they added 15 minutes. I wonder if I refresh if the timer will change. Oh, okay, yeah. Okay, yeah. Thanks for reminding me. That's, wow. I guess this is just some, like, JavaScript that's printing, like, some start time that doesn't refresh automatically, minus the contest length. Okay, yeah, maybe I'll switch to trying to do D1 with, the DFS solution that's, like, quadratic. Maybe that's a better use of our time. I do think there should be some kind of, like, not too complicated formula to compute this, but I'm sort of blanking on it, so I'll do that other thing. Okay. Okay, so what do we have? We've got 2 trees. So the first answer is n, m1, m2. And, oh yeah, this is one of the ones that doesn't have t. And then we read in m1 and m2 things. Okay, so call it forest 1, forest 2, for I in range first m1. Call it uv, I guess. uv equals okay, and then I need to add it. So if u in f1, if u not in f1, f1 at this is sort of annoying. I'm gonna have to rewrite this all with f2 instead of f1. This is why people write methods. So f1 at u should just be a set. And then same thing, v. And then I need to add it, so f1 at u dot add v okay, and then let's just rewrite the whole thing for the other tree, the other forest. Okay. And I'll just replace F1 with F2. Right. Find F1, go to the end. And that should be M2. Okay. So there I've got my input, my two forests. Okay, so now I want to do DFS to partition them into two sets. I'll write a method for this. So def DFS F. So what do I want this method to do? Takes in a dictionary describing a forest and returns a list of sets of connected components. Okay. So okay, so I'll keep track of the things that aren't allocated. So I'll call it unplaced. It should be just a set of 1 to n, or 0 to n-1, I guess. So I really hate how Python set doesn't have like a get element. Like just take any element out. I don't care which. I feel like that should like exist. I guess I can cast it to a list and take the first one, but it seems maybe inefficient. Sorry, we're not included. Okay, so I'll do it the other way around. I'll keep track of placed. And nothing is placed in the beginning. And then for I in range n, if I in placed, continue. And then let's keep track of the connected component. Okay, so connected component should be a set as well. Or I guess I can just have it start with just I. So the answer should be an array. Okay, so neighborhood equals just the neighbors of CC, so f at CC, while neighborhood is greater than 0. I'll say next equals another set for for I in neighborhood, cc.add I if for u in so that for u that's adjacent to I, so for u in f next to I, next dot add u. I need to place, I'll place them all at the end. I think add all exists or something. Okay. Okay, and then at the very end, I just say neighborhood equals next. Okay, and then at the very end, I'll just say answer equals plus equals this next connected component, and placed equals placed union cc. And then at the end, I'll return answer. Okay, let's see if this works. So DFS F1, F2. This is D now. Okay, unhashable type set. Try to hash this. Oh, I don't want CC, I want I. Oh, you know, this is bad. I think I want to pre-fill all of these actually with empty dictionaries. So for I in range M1, F1 at I equals a dictionary. And same thing for 2. Default dict. What's a default dict? Is that like where you don't pre-fill, if you just like if it, oh yeah, you can set it so like if it's not already in it, you just get like what you want, like 0 or empty set. That might be better. There's no add. Wait, it should be a set. Oh, right. I want it to be an empty set, not a dictionary. Key error 2. I'm just gonna subtract 1 from everything. I prefer to index from 0 here, I think. Didn't fix the problem. Oh, of course, this should actually be range n. Still didn't fix the problem. Wait, now why didn't it fix the problem? 26. Oh, I didn't subtract 1 there. Oh, I subtracted 1 from these, which I actually do not want to subtract 1 from. Key error 1 minus, oh. Okay. Okay, and now it's infinite loop. Oh, because I don't want to add everything to, I don't want to like go backwards here. So for u in f at I, I need to keep track of, oh, I can just say if it's in the connected component. For I neighborhoods, he said, yeah. So if u in f1, if u not in CC. Okay, and now it runs quick, and we get, wait, but did we print anything? We just didn't print anything? Oh, I didn't print them, right. Of course we didn't print anything. Okay, so it thinks everything's separate. So that's not good. You just see what my trees are looking like. Okay, so 0 is connected to 1. Okay, so there should be one connected component here. And there should be one connected component here. So yeah, so the first one we actually shouldn't print anything out. And then, oh, this is correct. Yeah. It's saying that there's, each one has one connected component. Okay, perfect. Let's see what it does for the second one. Okay, so for the second one, it's saying that each one has two, or the first one has two connected components and the second one has three. Let's see if they give us a picture. Okay, so we can see that 3, 4, 5, aka 2, 3, 4 are connected and 0, 1 are connected, and this one also has the same thing, 0, 2, 3, and 1, 4. Okay, perfect. So yeah, it looks just correct. Let me just check the last one. Why not? I can't read this, but it does sort of look like the first one is mostly disconnected. And wait, is the first one mostly disconnected? Oh yeah. So it's mostly just on its own. So 1 is connected to 7, so there's a connected component. Everything else is isolated, and the second one is 2. Okay, yeah, looks right. Okay, so now we've got our two partitions, and now we need to actually come up with an answer. So what am I going to do? I'm going to iterate through all possible edges. Yeah, I'm just going to iterate through all possible edges and add them in the order that they are permissible, I guess. So there's quadratically many edges, so this works in D1, but of course won't work in D2. So for I in range n, for j in range n, so if I guess I want a slightly different data structure that'll tell me if they are permissible. So instead of like a list of sets, I guess I want like a dictionary that just maps every vertex to what it's adjacent to. So I'll call it answer 2. It should be a dictionary, and then for I in range n, answer 2 at I should equal set, and then for CC in answer for so for CC in answer for I in CC for J in CC, if I does not equal J, then CC, or then answer 2 at I dot add J, and vice versa. And then what I actually want is answer 2. And then what do I do next? So I'm iterating through all possible edges, and then I will just say, so I'll call this D1 equals DFS F1. And then so if it's legal in both, then I add it. So if D1, if J not in D1 I and J not in D2 I, then what I want to do, I guess I'll call this answer. So answer should be a set. Answer dot add tuple ij. And what else do I have to do? I have to like now combine these two things into one. Okay. So for K in D1 at I, for, I'll say K1 and K2 in D1 at I, they're J. Then I need to say D1 at I dot add K2 and all the combinations. So I need to add that. I need to add that. And then I need to do the same thing for J. And that should be K1. And then I need to do the same thing for D2 as well, I suppose. Okay, this is now horrific. But it might be correct. Might be. Well, now let's just print answer, see if it works. error. My trademark trailing J's. Let's see if that works. Oh, I guess I have an extra print somewhere that I... Oh, no, this is what it thinks the answer is. Oh, of course, we're not going to add... We can just continue if I equals j. So if I equals j, continue. And this is, I guess, the correct answer. Sort of. Oh. Set change size during iteration. That can happen. Yeah, that's annoying. I'll make like a method. So what do we? So I want to define a method called fuse that accepts like the dictionary type thing, and the two vertices we want to fuse. And then let's see, so for n okay, so basically U was in a bunch of things with, U had a bunch of neighbors. How much time do we have? Shit, okay. So U had a bunch of neighbors, and I want them all to become neighbors of V. So for neighbor in du, so dv.add n, and then for neighbor of v, so for n1 in dv, then I'll just add that. So d at n1 dot add n, and I also should add u. And then I should do it the other way around as well. Maybe I can just call fuse dvu. Oh no, I can't do that, of course. Well, I can say if v is less than u, then I'll only call it once. Oh, I don't know. Whatever, I'll just rewrite it. And then just replace this with v. Replace this with u. And then I just call fuse the appropriate number of times. Where was I? Yeah, okay. So I want to fuse D1 IJ and D2 IJ. Okay. And now it's saying TED 04. Wait, why would it? Why would it do it both directions? Shouldn't they be added bidirectionally? But let's see, is 04 even a valid answer? I guess so. Yeah, so 04 is adding, yeah, it's adding these two. That seems perfectly fine. Oh, so I didn't solve that problem. For N and DV, where do I change D? Oh, I guess I might change DV. Oh, well, I guess we're out of time. 30 seconds. I feel like I got kind of cooked there towards the end. This extra 15 minutes didn't help me. Yeah, I feel like we were very close to E, but I missed some, I guess, combinatorial closed form formula that would have helped us. Yeah, because I think we just needed a big O n way to compute once GCD was no longer a consideration, which should like be almost always after you go 2 or 3 steps. Like this set of possible GCDs that aren't 1 is quite small. But yeah, I think I just missed that formula, and I don't know. By the time I got here, I think we were sort of cooked. I probably should have done this one before E. I probably should have trusted the problem set designers to put them in the right order of difficulty, but I just had convinced myself that like my solution was correct, even though it was actually quadratic in N or quadratic in M. I thought it was just big O NM, but it was big O NM squared, so quite bad. And yeah, I feel like I was pretty cooked by the time I got to this one, and that was, I guess, evidenced by how long it took me to write a correct DFS algorithm. And yeah, I probably should have thought more carefully about what we're doing. I wanted to do the most naive possible thing where we iterated over pairs IJ and just if they worked, added them, but then I didn't correctly implement the fuse. Yeah, I guess I probably shouldn't have worked in this way where there's like a dictionary that maps vertices to things they're adjacent to and then just checked whether they're in them. I probably should have worked in just like a list of connected components, and then it would have been a matter of just like making the connected components the same. And it probably still would have been plenty efficient to tell if IJ were in the same connected component. I could just like iterate through and find where they were. But whatever. At least we were fast on the first 3. See where we ended up. I imagine my rating will go down slightly because yeah, D and E weren't quite that hard, and we didn't really do the first 3 that fast. Looks like Codeforces being laggy again. Oh, okay. Well, I think we ended up around 3,000 out of 30,000, but maybe more like 2,000th. I don't know. Oh, is it loading? Okay, let's see. Oh, the contest is gone though. It's this one, right? Maybe I needed more coffee. I feel sort of like tired now. Oh, contest is probably the right place to go. Yeah, so we did the first three. Looks like 7,000 people did it. Oh yeah, so we probably ended up around 5,000 then. If 4.6K people got this one. Uh, Sort of a bummer. So yeah, yeah, not the best. I've not really done any Project Euler. I think I did like the first couple dozen at some point in college, but that's about it. Maybe I should do those more seriously and stream those. How about you? Do you like Project Euler? They're more mathematical in nature, right? Mm-hmm. Oh, don't stream them? Oh, yeah. Uh, oh, wow. I guess we did quite bad. Like, only top third. Yeah, definitely sort of messed up by trying to do E before D. I guess I'll just like look up I guess they post solutions, so I'll just read the formula when they do. But yeah, thanks everyone for watching. It was a lot of fun as always. Um, have a nice Sunday.